So today we're going to demonstrate how to collect an ATP swab. So ATP is a molecule that's found in all living cells, and it's often used in a food production environment to determine whether or not a surface has been adequately cleaned. So you usually collect your ATP swab before your sanitation step, but after cleaning, to verify that the cleaning was effective, that all of your soil was removed, but before you apply the sanitizer. And that's because a lot of our sanitizers can interfere with our ATP readings. And also, sanitizing does nothing to remove compounds like ATP. Sanitizers are effective for killing microorganisms, but not for removing soil in which ATP may be present. So we have our ATP swab here. There are a lot of identical swabs that look like this. You need to make sure that you're using one that matches the type of luminometer that you're using. And we'll show you a luminometer in a second. But make sure that you actually are using an ATP swab and not an allergen swab or a protein swab or another type of swab. What we've done is we have our template here. This is 10 centimeters by 10 centimeters. And so we put it on the surface that we're interested in swabbing. And so you open up your swab and start by sweeping the tip in one direction, so over the entire surface, and make sure that you're rotating it back and forth. So we'll go horizontally, and then we'll sweep it vertically, again, rotating the tip. And then finally, we'll do a sweep diagonally. Alright, so return your swab to the tube. Then you have this liquid reagent at the top, so you snap the top in order to release it into the tube and shake it lightly for about 5 seconds in order to mix the reagent with the sample and any contamination that may be present on the swab. Then the piece of equipment that you use to measure the amount of ATP is called a luminometer. And so what this does is it measures the relative light units, which is a direct relationship between the amount of ATP or the amount of contamination that was on the surface. So generally, a higher RLU value means that there's more contamination on the surface. So open the luminometer. You want to keep it upright the entire time that it's reading. And then you hit your OK or read button. And it takes about 15 seconds to read the result. Now you want to make sure after you collect your swab that you test the swab and the reagent within about 60 seconds of the time it's collected. So don't collect a swab and let it sit around for a while before you actually get your reading. So we've gotten our RLU value, which is our indicator of how much ATP is on the surface. Now, one of the issues that you have in a produce packing house, and especially an open one like this, is the fact that a lot of the manufacturer recommendations are geared towards the medical field or even for food processing in an indoor, very controlled environment. So a packing house, you're going to expect to have higher levels than the manufacturer recommendation. So what you have to do is determine what your acceptable baseline is for your facility. Now, the best way to do this is to thoroughly monitor your cleaning crew over the period of a few weeks. Make sure that they go through their normal cleaning procedures as normal, and collect your ATP readings at the end of each cleaning cycle. So particularly in an outdoor packing environment like this, a 56 RLU reading is pretty phenomenal. So you're probably going to be having a higher target that you're shooting for, just because you do get dust and debris moving its way through. So really the best you can do is make sure that your cleaning crew is working effectively when you're trying to determine your baseline, so you know your baseline is appropriate. So another type of swab we can use is a protein swab. This is less effective in a produce packing house where you're not expecting to have high quantities of protein. But some audit schemes actually allow you to use protein swabs as a verification of your cleaning program. One thing to keep in mind with the protein swab is you don't need a luminometer. So even though the protein swab looks identical to our ATP swab, you don't have to buy the piece of equipment to get your results. So you collect your sample very much the same way as your ATP swab. So again, sweep across the surface while rotating the swab. You're going to do this in multiple directions. Then you return your swab to the tube. Again, release the reagent. and let it mix with the sample. So we let the sample contact the liquid for about a minute. And the nice thing about these protein swabs is they're really easy to read. There's little interpretation as far as needing a numeric value. You have a nice little color chart on the back of the tube. So our green is go, or is good. So that means that our surface is relatively free of protein. Our gray may indicate that there's a little present. You need to determine what your risk tolerance is for there possibly being protein carryover. And then if you start getting pink or purple on your swab, that means that there is a good deal of protein present, and you might need to revisit your cleaning process again before you start running new product on the line. So here, it's been about a minute, and our swab is still green, so this indicates that there's no protein on the surface and that our cleaning procedures were effective to remove any protein contamination if it was actually present.